Okay folks, buckle up, because tonight on the Mysteria archive, we're diving into the stories CERN doesn't tell in the press releases. What if, while searching for the origins of reality, we tore a hole straight through it and something was watching on the other side? Get ready for a wild ride. What if the universe has a reflection? Beneath the rolling fields of Switzerland, a machine sleeps in a ring of metal and fire. 17 miles wide, it waits, silent, patient, until someone presses the button that makes the universe remember how it began. They built it to find the invisible, to glimpse what makes up 95% of everything we know: dark matter, dark energy, the hidden half of reality. But what if, when the beams collided, something looked back? Physicists call it data. Fringe theorists call it a mirror. They say that every flash inside CERN's tunnels might not just reveal the unknown, it might awaken it. A reflection world, perfectly balanced but unseen, pushing against the edges of our own. And tonight, we're going to step up to that glass, because maybe the greatest experiment in history isn't about discovering the dark side of reality. Maybe it's about meeting it. Okay, dramatic start, I know, but come on, if your world-ending particle collider doesn't get a movie trailer intro, what's the point? So yes, CERN's real. The Large Hadron Collider actually does fling protons around a 17-mile ring under Switzerland. But the dark reflection idea, that's where science and imagination start slow dancing. And honestly, if I had access to a machine that could peek behind the curtain of the universe, I'd probably check twice before hitting the on switch. Anyway, before we start worrying about mirror versions of ourselves, let's talk about what this dark universe actually is. Dark matter, the hidden 95% of reality. Everything we can see, planets, stars, people, your phone, even the air, is only 5% of the universe. The rest is invisible. Scientists call it dark matter and dark energy, forces that can't be seen, only felt through their gravity. For decades, physicists have been chasing clues: galaxies spinning faster than they should, light bending around empty space, clusters of stars behaving like someone unseen is tugging the strings. Whatever's doing it outweighs normal matter 5 to 1. It holds galaxies together, shapes the universe, and yet it doesn't glow, reflect, or collide the way ordinary atoms do. That's where CERN enters the picture. Buried deep beneath Geneva, the Large Hadron Collider was built to smash protons so violently that fragments of the early universe flicker back into being. Each collision is a rewind button, an attempt to recreate the conditions just moments after the Big Bang, when light and darkness first separated. And detectors like ATLAS and CMS watch for hints of particles that shouldn't exist, ghostly fingerprints of whatever makes up that missing 95%. Some scientists think these dark particles might have twins of their own, mirror versions that exist in hidden frameworks overlapping our own. If that's true, then everything, our bodies, our planet, even time itself, might have an unseen counterpart quietly running beside it. But here's the riddle. If dark matter is everywhere, why can't we touch it, see it, or trap it? It's like gravity from a ghost, powerful, precise, and absolutely untouchable. And the deeper CERN digs, the stranger the math becomes. Because the more we learn about the visible world, the more obvious it is that most of reality is missing. So, quick recap. 95% of the universe is apparently playing hide and seek, and we're losing. Scientists have billion-dollar machines, and dark matter's just standing behind the cosmic couch going, "You're getting warmer." But that's what makes it fascinating. CERN isn't chasing ghosts, it's trying to prove ghosts have mass. And if even one of those collisions reveals something new, we're not just rewriting physics, we're opening a door that's been locked since the Big Bang. Next up, we'll see what happens when matter meets its opposite, and why some people think CERN's knocking on the entrance to a shadow realm. CERN antimatter experiments and the shadow realm. Deep underground, at the heart of CERN's massive complex, a handful of experiments are running that sound like science fiction, except they're not. They're about antimatter. Antimatter is the mirror twin of normal matter, identical in every way, but with the opposite electric charge. When matter and antimatter meet, They annihilate each other. Pure energy gone in a flash. And that's the mystery. According to physics, the Big Bang should have created equal amounts of matter and antimatter. But that didn't happen. Something broke the balance. Our universe won, and its twin, its reflection, vanished. At least that's the official story. Inside the Alpha, LHCb and Atlas experiments, scientists are testing that balance. They trap individual atoms of antihydrogen, measure their charge, watch how they fall and how they react to gravity, searching for even the smallest difference. So far, the results say matter and antimatter behave almost identically. Almost. But almost might be everything. Because if that symmetry ever breaks, even slightly, it could mean the two sides of creation still exist, one made of matter, one of antimatter. Two universes split at the moment of birth, still linked through gravity, through quantum threads, through something we don't yet understand. Fringe theorists call it the shadow realm, a parallel cosmos made of inverted energy, the missing reflection of our own. Some even speculate that every time the Large Hadron Collider fires, it doesn't just recreate the early universe, it briefly reconnects it. Tiny bridges, quantum whispers, passing between the light and its shadow. The math says it shouldn't happen. But the universe, as always, seems to have a habit of ignoring our equations. Okay, so antimatter is basically the universe's evil twin, except instead of a goatee, it just explodes if you touch it. Now, CERN's not summoning demons here. They're literally studying physics so delicate that even gravity might play favourites. But that's the thing. The more they search, the more symmetrical everything seems. And yet, clearly, something tipped the scale or none of us would exist. So maybe the shadow realm isn't hellfire. It's just the half of creation that drew the short straw. Still, if there's a mirror universe out there made of antimatter, let's hope they're not also building their own collider. Ancient myths of the mirror world. Long before particle accelerators or quantum equations, humanity already believed the universe had two sides. Every ancient culture told stories of a mirrored realm, a reflection of our own, separated by light, by death, or by divine law. The Egyptians called it Duat, the shadow world beneath reality, where the soul travelled after death. To the Hermetic philosophers, the cosmos was a correspondence, as above, so below. Whatever happened in the heavens had an echo on earth. The Gnostics spoke of the pleroma, the divine realm, and its flawed reflection, the material world. And in Jewish mysticism, the Qliphoth was the dark inversion of the tree of life, a world where creation's leftovers, the shadow of divinity, still clung to its existence. It's strange, isn't it? These ancient myths weren't describing galaxies or particles, but the pattern feels familiar. A world of light and one of shadow, a perfect symmetry. And modern physicists might use different words, dark matter, antimatter, mirror particles, but they're all describing balance, two halves of a whole. Maybe what ancient mystics called the veil wasn't spiritual metaphor at all. Maybe it was intuition, humanity's earliest attempt to describe what science is only now proving with math. Because when you strip away the poetry, the story is the same. There's something behind the visible world, a twin, a copy, a reflection that shapes the original. CERN isn't the first to look for it. It's just the first to build a 17-mile ring of fire to do it. And somewhere between sacred text and superconducting magnets, both sides of the story begin to sound the same. You've got to admit, the ancients were way ahead of the curve. They didn't need billion-dollar colliders, just incense and imagination. But it's wild how those old myths line up with modern physics. Dark matter, the Qliphoth, Duat, different languages, same idea. The world has a hidden twin. Of course, if I told ancient Egyptians about mirror particles, they'd probably just nod and say, yeah, we call it the afterlife. So, maybe science is catching up to the poetry. Or maybe we've been describing the same mystery all along, one through equations, the other through story. Parallel universe theory and the CERN connection. In 2018, two physicists, Latham Boyle and Neil Turok, proposed something radical. They suggested that the Big Bang didn't just create one universe, it created two. Ours made of matter, and the other, its mirror, made of antimatter, where time itself flows backward. Think of it like a reflection in glass. Every event in our universe, every explosion, every heartbeat, every thought might have an opposite version playing in reverse, forever balancing the cosmic equation. The theory is called the CPT symmetric universe model. In it, the laws of physics don't break when mirrored, they complete themselves. And suddenly, that makes a strange kind of sense. For decades, scientists have puzzled over why the universe favors matter. But what if it doesn't? What if everything missing here, antimatter, dark energy, the invisible structure holding galaxies together, isn't lost, but exists on the other side of the reflection? That's where CERN comes in. When the Large Hadron Collider smashes particles together, it doesn't just recreate conditions from the Big Bang. It might momentarily echo the birth of both universes. And if that mirror world still exists, every high-energy collision could send a ripple across the divide. Some experiments have already hinted at anomalies that can't be explained by our known physics, brief ghost signals, flashes of that data that vanish as quickly as they appear. To mainstream science, these are statistical noise, but to others, they might be a glimpse of something else. Imagine it, a mirror universe operating in perfect reverse, just a quantum's hair's breadth away. Invisible but gravitationally linked, its fingerprints hidden in the patterns of our own cosmic background. And every time CERN fires up, maybe, just maybe, the two reflections meet for a fraction of a second. Okay, so a universe running backward in time. That's basically the movie Tenet, but with fewer car chases and more math. And by the way, Tenet was a great movie. Come on, Chris Nolan, where is Tenet 2? Now, this CPT symmetry idea is real science. It's not fantasy. The whole time reverse twin universe thing actually solves a bunch of physics problems in one go. Still, it raises an uncomfortable thought. If there really is a mirror world running opposite to us, are we the originals or the reflections? And honestly, if my mirror self could stop making all the same mistakes, that'd be great. All right, let's see what happens when those mirror theories start showing up in the actual data. Quantum anomalies and the hidden sector. At CERN, anomalies are both a scientist's dream and their nightmare. They mean you found something unexpected, something that doesn't fit. And lately, the data has been whispering secrets. Tiny deviations, particles appearing to break rules they've obeyed for decades. Strange readings that suggest forces we don't yet understand. Take the muon anomaly. In 2021, researchers found that muons, those heavier cousins of electrons, were wobbling in magnetic fields in ways the standard model couldn't predict. It was small, barely measurable, but unmistakable. Something unseen was tugging at them. Then there are the sterile neutrinos, ghost particles that don't interact with matter at all, only gravity. They shouldn't exist, yet experiments keep catching faint hints that they do. Scientists call this the hidden sector, a theoretical realm of unknown particles and forces that could explain dark matter, dark energy, and maybe even gravity itself. It's like discovering that there's a secret room in a house you thought you knew inside out. CERN's detectors, ATLAS, CMS, LHCb, are all listening for signs of that hidden world. Most signals turn out to be noise, false positives, coincidences, but a few linger. Some theorists think these anomalies are the fingerprints of mirror matter interacting with ours, a kind of cosmic bleed-through, tiny exchanges between our universe and its shadow. If true, every data blip could be a message from the other side of reality. And here's the haunting part. The more precisely CERN measures, the less complete our universe seems, like we've been staring at only half the equation all along. So yeah, hidden sector sounds like the name of a spy agency, but it's just science's way of saying we have no idea what this is. Now, these anomalies are tiny, like microscopic breadcrumbs leading to something huge. Of course, skeptics say it's all noise, but then again, every great discovery in physics started as just noise. And if these weird signals really are our reflection trying to say hello, maybe the universe is less like a machine and more like a conversation, one we've only just learned how to hear. The human shadow and cosmic consciousness. Here's a strange thought. What if the mirror universe isn't just out there in space, but inside us? Because just like the cosmos, The human mind has its own dark matter, hidden forces that shape everything we do but can't be directly observed. Neuroscientists have found that most of our brain's activity happens below conscious awareness. Silent circuits, background noise, decisions made before we even know we've made them. Carl Jung called this our shadow self, the unseen mirror of our consciousness, holding everything we suppress or deny. Now, think about that cosmic symmetry again. Light and dark, visible and hidden. Physics describes the universe the same way. Most of what exists is unseen, but deeply influential, just like the human psyche. Fringe philosophers and metaphysicists have long speculated that consciousness itself might act like a bridge between dimensions, a kind of quantum observer that shapes reality through perception. The old Hermetic saying, "as within, so without," wasn't just spiritual poetry, it might be literal. If our consciousness mirrors the structure of the universe, then maybe CERN's search for hidden matter is also a reflection of something internal, a scientific expression of humanity trying to find its other half. Because whether you're talking about psychology or physics, one truth seems to repeat: everything that exists has a shadow. And when we look into that shadow, whether through a collider or a mirror, we're not just discovering the unknown, we're meeting the rest of ourselves. Kind of poetic, right? The idea that the universe might have a subconscious, and CERN's just trying to put it under a microscope. Now, Jung probably would have loved that, particle physics as therapy for the cosmos. Of course, scientists roll their eyes at cosmic consciousness, but you can't deny the symmetry. The more we look outward, the more the pattern repeats inward. And maybe that's not coincidence. Or maybe it's just the universe reminding us that it built the same architecture, neural, cosmic or quantum, on every level. Either way, it's weirdly comforting to think reality dreams too. CERN Symbolism and the Alchemy of Creation. Before you dismiss the symbolism around CERN as superstition, take a closer look. The architecture, the imagery, even the language, all of it tells a story older than science itself. Start with the collider's shape, a perfect circle. Physically, it's practical. Particles can accelerate continuously. But symbolically, the circle represents eternity, rebirth, the Ouroboros, the serpent eating its own tail. The ancient symbol of unity between destruction and creation, exactly what CERN does, colliding matter to glimpse the moment of its birth. Then there's the Shiva statue at CERN's entrance. Shiva, the Hindu god of creation and destruction. It's not an idol of worship, but a gift from India. Still, it's poetic. Shiva dances the universe into being and then back into nothingness, just like the particles below. It's hard not to see the resonance. Even the quest for the Higgs boson, the so-called God particle, echoes alchemy. Ancient alchemists sought the prima materia, the original substance of creation, hidden behind illusion. CERN scientists are doing the same thing, but with magnets instead of mysticism. They're breaking matter down to its essence, asking the same ancient question: what makes reality real? To the modern world, CERN is physics. To the ancient mind, it would have been a ritual, a reenactment of creation itself. The Ouroboros turning, Shiva's dance, the alchemical fire below the earth. Maybe that's not coincidence. Maybe it's memory, science rediscovering the language of its own mythology. Yeah, I know. Once you start mentioning Shiva and alchemy, people either lean in or switch off. But honestly, it's fascinating how much symbolism sneaks into modern science. We dress it in equations now, but the impulse is the same: understand creation. CERN isn't performing a ritual, but the human imagination kind of is. And maybe that's the real magic here. When we build machines to uncover the universe, we're also retelling ancient myths with better graphics. Just, hopefully without accidentally summoning anything. Quantum portals and the physics of the veil. At the quantum level, reality gets strange. Particles blink in and out of existence. They teleport information across space instantly, as if distance doesn't even matter. Physicists call it entanglement, a connection so deep that two particles can share a single state, no matter how far apart they are. Einstein famously called it spooky action at a distance. Now, imagine scaling that up, not just two particles, but two universes. In string theory, the fabric of the cosmos isn't flat, it's layered, made of vibrating brains, stacked within higher dimensions. Our universe could be just one of those brains. If another one lies close enough, separated by a fraction of a millimeter in higher dimensional space, then under the right conditions, extreme energy, magnetic resonance, or gravitational interference, information could bleed across. It wouldn't be a portal in the science fiction sense. No swirling doorway, no one walking through. It would be resonance, a brief frequency overlap where two realities synchronize. And that's what fascinates some theorists about CERN. The collider's immense magnetic fields, rotating protons, and shockwave, like collisions, might unintentionally brush against that boundary. The veil between universes may not be solid. It may be a standing wave of energy, vibrating just out of phase with ours. When those frequencies align, even for a nanosecond, strange things can happen. Particles that vanish, signals that appear from nowhere, brief distortions in expected data. To physicists, it's a puzzle. To others, it's evidence. If reality really is layered, then CERN might not be breaking through the veil. It might just be tuning the dial. Okay, before anyone starts picturing Doctor Strange at CERN, it's worth saying no one's opening literal portals here. But the science is wild. Entanglement and brain theory sound like sci-fi, but they're legitimate physics problems. Still, it's eerie to think that by smashing protons together, we might occasionally hit the universe's sweet spot, the cosmic equivalent of harmonizing two strings on a guitar. And if that's true, maybe the veil isn't a door at all. Maybe it's a song, and CERN just learned a few of its notes. Reality glitches and signs of the mirror universe. Sometimes the anomalies aren't confined to the lab. They show up in the sky, in sensors, and even in the subtle ways reality seems to flicker. CERN's detectors have occasionally recorded events that defy categorization. Signals that appear, vanish, and never repeat. Cosmic ray observatories around the world detect high-energy particles that shouldn't exist, traveling faster than theory allows. And deep underground, neutrino detectors catch phantom bursts that seem to come from nowhere. Scientists chalk these up to noise, instrument error, or misinterpretation. But some fringe thinkers see something else. Cross-light moments where two universes momentarily overlap, and their physics blur. It's not just the data either. There are physiological and cultural echoes too. People describing shared déjà vu, moments where time seems to slip, memory fragments, or the world feels out of sync. Science calls it coincidence. But if the two realities do occasionally resonate, maybe those moments are the human version of a detector spike, a consciousness-level blip when the mirror flickers. Even the language scientists use betrays the poetry of it. CERN's collisions create luminosity events. The detectors capture reflections. The words sound almost mythic, as if modern physics is describing ancient phenomena in a new dialect. The deeper we stare into the quantum field, the more it stares back in patterns we don't quite understand. And if these reality glitches really are glimpses through the veil, then maybe we're not just studying the universe anymore. Maybe we've started to make eye contact with it. You ever have one of those moments where reality feels like it skipped a frame? Like something shifted, but you can't quite explain what? That's what this reminds me of. Now, science will tell you it's just perception or fatigue, and it probably is, but still, the thought that glitches in space-time could ripple all the way down to human experience? That's unsettling in the coolest way possible, because maybe CERN isn't creating these effects. Maybe it's just giving us the language to notice them. The dark universe watching back. It's easy to think of dark matter as something far away, out in deep space, scattered between galaxies, light years beyond our reach. But maybe it's closer than we imagine. Because if everything we've seen, the anomalies, the mirror models, the flickering data, is even half right, then the universe isn't just a one-way mirror, it's a conversation. A dialogue between the seen and the unseen, between the world we know and the one that's been quietly orbiting it all along. Every time CERN's beams ignite, we peel back a little more of that veil. We shine a light into what used to be pure darkness. But what if that darkness isn't empty? What if it's alive, conscious in a way we can't yet understand? A shadow universe bound to ours, moving in perfect counterpoint, like two dancers caught in a cosmic waltz, each shaping the other's steps. Maybe that's why our physics feels incomplete, why gravity leaks into nothing, why time feels flexible, why reality itself sometimes flickers. Because half the equation has been missing, not destroyed, just inverted, hidden, watching. The ancients called it the other side of the veil. Physicists call it the hidden sector, different names for the same mystery. So maybe CERN isn't breaking reality, it's tapping the glass. And every now and then, when those detectors hum and the data spikes, maybe the universe taps back. Not to warn us, not to harm us, but to remind us that discovery always goes both ways. Because the greatest revelation might not be that we finally found the dark universe, but that it's been aware of us this whole time. And that's the part that always gets me. We build machines to explore the universe, but what if the universe has been studying us too? It's like trying to map your reflection while the mirror starts mapping you back. Now, I'm not saying CERN has opened a portal or awakened a cosmic twin, but it's hard to ignore how much mystery is left in the data. If nothing else, maybe the dark side of reality isn't something to fear. Maybe it's just the rest of the story finally showing its face. Thank you for watching, and I hope you enjoyed this one. And if so, why not check out the video on screen at the end? And if you'd like to support the channel further, I've just launched a Patreon site and YouTube memberships where you can get proper community chat and exclusive content on Mondays. Links in the description below. And as always, don't forget to like, share and subscribe. It really helps the channel out and I'd really appreciate it. Let me know in the comments below videos you would like to see next time. Okay, my friends, be safe. And until next time, stay curious.